Hello, this is Adolf. Welcome to video lecture series on the course of design of steel structure. We are going to say about connections in steel structure. So in this unit, we have two important connections, that is riveted connection and welded connection. Under riveted connection, we are going to see about what are the types of rivet and their use, types of riveted joint and its failure, strength of riveted joint and efficiency of a riveted joint, what are the assumptions used in the theory of riveted joint, and finally we have to design a riveted joint for axially loaded member. Under the welded connections, we are going to see about permissible stress in weld, strength of weld, advantages and disadvantages of welded joint, what are the types of weld and their symbols, and design of fillet weld and butt weld subjected to axial load. The content of this video lecture is, first we are going to see about the introduction, second what is the procedure of inserting a rivet and what are the types of rivet available in the market, third what are the types of riveted joints we are going to use in the steel structure, and finally what are the failures of the riveted joints. First we start with the introduction. A rivet is made up of a round ductile steel bar piece with mostly mild or tensile steel called shank with the head at one end. This is how your rivet will look like. So it is having a head at one end and free at other end. So this head is also called as manufacturer's head, and the head at the other end made at site we call it as a driven head. This one is a manufacturer head, this one is driven head. The size of the rivet is the diameter of the shank. So this part is shank. The diameter of the rivet we call it as the size diameter of the shank only. We will call the size of the rivet. The diameter of the shank is called the nominal diameter since the actual diameter in joints are different. The common diameters that are used in steel construction are 16 mm, 20 mm, 24 mm, 30 mm and 36 mm. So these are the rivets and this is how the connection will look like. Let's see the procedure for inserting rivet. First we have to drill or punch a hole in the place where it to be riveted. The size of the hole is, if your rivet size is less than 25 mm, we have to add 1.5 mm with the size of the hole. If your rivet size is greater than 25 mm, we have to add 2 mm with the size of the hole. So for riveting, a rivet is heated uniformly to light red color and then placed in a hole. The head is kept pressed on the plate while the projected shank is hammered to form another head, that is driven head. So what happened on cooling the rivet will contract and grips the plate tightly. We have to insert rivet in the rivet hole by means of hydraulic or by pneumatic power. So according to that, driven methods, it was categorized into 4 types. First one is power driven shop rivets. These are fabricated in the shop itself. Second one is power driven field rivets. These will be inserted the rivet at the site. Third one is hand driven rivets. This will use pneumatic powers to insert the rivet in the rivet hole. But these hand driven rivets have less strength than compared with the power driven rivets. And finally we have cold driven rivets. These cold driven rivets will be used when the diameter of the rivets not more than 10 mm. The video shows how that power driven rivets are inserted in the rivet hole at the fabrication shop itself. Types of rivets. Under the types of rivet, the first we are going to see about solid rivets. These solid rivets, also known as round rivets. The solid rivets have been around for thousands of years with us, with some of the earliest examples dated back to the Bronze Age. The features a traditional design consists of a shaft and head. To install a solid rivet, manufacturers using a pressing tool that causes the shaft to deform and expand after being driven into the product of workpiece. These are the different types in the solid heads. For snap head, pan head, mushroom head, countersunk head, flat countersunk head at 90 degree, flat countersunk head at 60 degree, round countersunk head at 60 degree, and flat head. So see here, in every type the head of the rivet is differ. According to that only we are having the names. Next is structural steel rivets. Structural steel rivets feature a similar design as solid rivets, but they are designed specifically for use in high stress commercial construction application. These structural steel rivets made up of steel. They are used in the construction of bridges, high-rise buildings, storage sheds, and more. The structural steel rivets are typically heated in a furnace prior to installation to make the metal softer, more flexible, and easier to work with. Third one is split rivets. The video shows how we are inserting the split rivets into the wooden pieces. The split rivets features a unique design in which the shafts split into opposite direction. Like this, the shafts are split into opposite direction. When a split rivet is driven into a product or workpiece, the shaft expands in opposite direction. See, he is inserting this split rivet, then he is hammering the shaft into the opposite direction. This makes split rivets ideal for use in products and workpieces made of soft materials like plastic or wood materials. The fourth type of rivet is blind rivets. So this is how the blind rivets will look like, and this is the rivet gun. So these blind rivets, also known as pop rivets. So blind rivets consist of both a rivet as well as mandrel. A tool known as rivet gun is used to manipulate the mandrel during installation, allowing the rivet to deform and expand into the product or workpiece. The video shows how we are inserting the blind rivets into the product. These rivets are used widely in aircraft industries, shipping industries, and in many electronic industries. The main advantage of these rivets that they have the fastest rate of installation among all fasteners. One more benefit is that this can be installed from the single side. A blind rivet is used when it is impossible to see rivet tails. Fifth, flush rivets. A flush rivet is used primarily on exterior metal surface where good appearance and the elimination of unnecessary aerodynamic drags are important. These flush rivets takes advantage of a countersunk hole, so they are also commonly referred to as countersunk rivets. These countersunk or flush rivets are used extensively on the exterior of aircraft for aerodynamic reasons such as to reduce drag and turbulence. Sixth one, friction lock rivets. These resembles an expanding bolt. The blind end may be either countersunk or dome shaped. Friction lock rivets are designed to lock into place once the shaft extends deep enough into the product or workpiece. Unlike most other rivets, the shaft of a friction rivet won't expand until it's been driven deep into the product or workpiece. Friction locks were available in two styles. First one, hollow shank pull-through and self-plugging type. The pull-through type is no longer common. However, the self-plugging cherry friction lock rivet is still used for repairing light aircraft. Next heading, types of riveted joint. There are two types of joint. First one, lap joint. Second one is butt joint. Let's start with the lap joint. Two members to be connected or overlap and connected together as shown in the figure or in the video. Such a joint is called lap joint. There are two types of lap joint. Single riveted lap joint and double riveted lap joint are shown in the figure. A load in the lap joint has eccentricity. Why? Because the center of gravity of load in one member and the second member are not in same line. Therefore, a couple is formed which causes undesirable bending in the connection. To avoid these couple, we have to give the rivet in a line. Also, due to the eccentricity, the stresses are distributed unevenly across the contact area between the rivets and the members to be connected. This puts a limitation on the use of lap joint. Second, butt joint. The video shows how the rivets are connected in the butt joint. The two members to be connected are placed end to end. An additional plate provided on either one or both sides called cover plate and are connected to the main plates by using rivets. If the cover plates is provided on one side, it is called a single cover butt joint. But if the cover plates are provided on both the sides of main plate, it is called a double cover butt joints. In case of a double cover butt joints, eccentricity of force does not exist and hence bending is eliminated, whereas it exists in the case of lap joint. That's why we choose butt joint instead of lap joint. Next topic is failure of riveted joints. Under the failure of riveted joint, the first failure is shear failure of rivets. Plates riveted together and subjected to tensile load may result in the shear of the rivets. When the load is applied, the plates may slip due to applied forces. Due to that, rivets are sheared across their sectional areas. Single shear occurring in a lap joint and double shear occurring in the butt joint. So, this is a plate due to the tensile load. The rivet failed. It slipped away from its position. Second is bearing failure of rivets. The diagram shows how the rivets get crushed. The rivet is crushed around half circumferences. This will happen when the plate may be strong in bearing and the heaviest stressed plate may press the rivet, so that the rivet is crushed by the plate. Third one, shear failure of plates. When the rivet placed at a lesser edge distance than specified causes this failure. The plate may fail in shear along two lines. This can be checked by providing proper edge distance between the center of the hole and the end of the plate as specified by the IS 800. The diagram shows how the plate failed by the shear stress. Fourth one, tension or tearing failure of plates. When the plates are riveted together or carrying tensile load, tearing failure of plate may occur. When the strength of the plate is less than that of rivets, tearing failure occurs at the net cross-sectional area. So if the plate strength of the plate is less than that the rivet, tensile or tearing failure will occur. Fifth one, splitting or cracking failure of plates at the edges. Rivets may have been placed at a lesser edge distance than required, causing the plates to split or shear out. So if the edge distance is very lesser, it will cause the plate to split or shear out. Next is bearing failure of plates. Bearing failure of a plate may occur because of insufficient edge distance in the riveted joint. Crushing of plate against the bearing of rivet takes place in such failure. These are the failures of riveted joint. In these failures of riveted joint, three failures can be eliminated by using minimum pitch distance and minimum end distance. That three failures are shearing failure of plate, bearing failure of plate, and splitting or cracking failure of the plate. These three failures can be eliminated by using minimum pitch distance and minimum end distance. Next topic is advantages and disadvantages of riveted connection. The advantages of riveted connection. The process of riveting is very easy. Second point, it isn't permanent in nature and it has very low maintenance cost. Riveted connection is possible without electricity in any area and cheaper fabrication cost. Any two dissimilar metals can also be joined. Even non-metallic joints are possible with riveted joints. And what are the disadvantages of rivets? Necessity of preheating the rivet prior to driving. Before we are inserting the rivet, we have to heat the rivet. So that is one disadvantages. And it will have a high level of noise. Third, we need a skilled labor for inspection of connection, and the labor cost who are inserting these rivets are very high. So in this video, we saw the introduction and the procedure of inserting the rivet. Next, we saw what are the types of rivets available. Then what are the types of riveted connections available. Then what are the failures in the riveted joints. And we saw the advantages and disadvantages of the riveted connections. Thank you.